Break your leg, break the knot and break your leg, break 'em. Break your leg, break the knot.
Oh, hey guys. Well, sorry, I was filming a dance video there. Sorry about that. Well, I hope you're having a good Wednesday. Just a couple quick things. First of all, desktop stores due Friday. Make sure that you take care of that, get that done, submit it before then. Oh, make sure it's completed too. And then also, we'll have a help session after school today. You're more than welcome to hang out. If you'd like to call home or text home, let your parents know. I'll be available till about 5:15 p.m. So if you want to stay after school and get any extra help, that would be cool. Well, hey, here's what we're doing today. There is one type of equation left that you haven't seen yet. And so my goal when you leave today is to make sure that you understand how that equation works, what it looks like, and basically just to get some help with solving it. But before I show you that equation, I did want to show you kind of where we've been over the last 3 weeks so that you could get a really good idea of the progress you've made. So we started here about 3 weeks ago with one-step equations, and we solved those, and then we moved on to two-step equations last week. If you're in my advanced class, you might remember we solved two-step equations with fractions. Yesterday, of course, we started multi-step equations where you have to use the distributive property first, then solve the equation. We also looked at multi-step equations where you have to combine like terms first, then solve the equation. And then yesterday, of course, we finished with this guy, which is an equation where you have to use the distributive property first, then combine your like terms, then solve. So that brings us to the end. It's the last type of equation, and you might not have seen this one coming, but here's the last type. So what's different? Well, you probably noticed that this is an equation that has a variable on both sides. And it looks like it might actually be the hardest, but ironically, it turns out it's not so challenging because with equations that have variable on both sides, you have a choice. And so that's where our conversation begins today. So throughout our mini lesson today, we're going to be working on this document. This is the document that you made in the last step if you were following along on Edmodo. You'll notice that we have an area up here where we're going to write down some important ideas about solving equations with variable on both sides. Right here, we'll put down an example, which we'll actually do in just a second coming up together. And then you'll have 6 practice problems that you can do independently by yourself. So let's get started here. Let me get the problem. So here's the problem that we'll be working with. You'll notice that there is a variable on both sides. And you might be thinking to yourself, wait a second, why are there 2 equations on the screen? Well, that's because with equations that have a variable on both sides, you actually have a choice. So I wanted to show you both of those choices so that you could see either choice will get you the correct solution. So let's start over here with the equation on the left. So as always, your first step is going to be to stay organized. So let me just get these in here real quick. Cool. So you have a choice here. You can either have all of your variables on the left-hand side, or you can have all of your variables on the right-hand side. But you can't have them on both, which is why you have a decision to make. You can either have all of your variables over here on the left-hand side, or you can have all of your variables over here on the right-hand side. Now, just for the sake of argument, let's say that you like to have all of your variables on the left-hand side. Well, if that's true and you want all of your variables over here, then technically negative 9x can't be on the right-hand side. So you got to ask yourself a question. How do you get rid of or eliminate a negative 9x? Well, you would add 9x to both sides. So on the left-hand side, you would be 2x plus 13 equals, and on the right-hand side, negative 9x plus 9x is 0, which is awesome because we wanted all of our variables to be on the left-hand side anyways, equals 21. You'll notice this is just a standard two-step equation now, so you can take away 13 from both sides. and you'll get 2x equals 8. Divide both sides by 2. And you'll determine that the mystery number is 4. And that means that if you put the mystery number here and calculate this side, it will equal this side with the mystery number replaced here. Now remember, a few moments ago I told you that you actually have a choice. You can have all of your variables on the left-hand side, or you can have all of your variables on the right-hand side. For this particular example, we put all of our variables on the left, which means that I wanted to show you that you could have also picked the right and gotten the same solution. So, on the right-hand side, I'll go ahead and get our equation set up. And we'd like all of our variables to be over here on the right. So you'll notice that we have negative 7x on the left-hand side. So you have to ask yourself, how do you get rid of or eliminate a negative 7x? Well, the inverse operation is add, so you'd add 7x to this side, add 7x to this side. You'd be left over here with 13, because negative 7x plus 7x is 0, equals negative 2x plus 21. Take away 21 from both sides. You'll get negative 8 equals negative 2x. Divide both sides by negative 2. And you'll get x equals 4. Which is the same solution. So as you can tell, when you solve an equation with variable on both sides, the first thing that you do is decide which side you'd like all of your variables on, and you move them to that side. Then after that, you can go ahead and solve your problem like normal. And you'll get the same answer whether you pick the left side or the right side.